Hi students, today we are going to observe sequences and series. So before going to that, we know the proverb like numbers rule the world. Numbers rule the world. What is the meaning? If you observe the world anywhere, we can observe many numbers. Without numbers, there is no world at all, right? Yeah. Now, if you observe the numbers, suppose I am writing the numbers like this. Let me write the numbers. Write the beautiful numbers 1, 2, 3, 4, 5, so on, so on. Okay, this is one kind. And another one I am going to write 5, 10, 15, 20, so on. And another way I am going to write like -3, -6, -9. This is one kind of pattern. Yes, you can observe there are in all these cases, this is one kind of pattern and this is another kind, this is the other, right? If you observe this kind of patterns, each number with the other number there is some relation between the numbers. That is from first number to second or second to third or third to fourth, like that. There is some relation, or we can say that this can also be called as a rule, right? Yeah. So now if you observe the numbers, these can be called these as successive numbers, right? Okay. Or here successive numbers. So, but in this pattern, I can call these as successive numbers. Okay. Now, successive, instead of calling each number, can I call it as a term? Okay. Term. Okay. So this is first term, second term, third term, fourth term, four terms. And it is going on. It goes like this. Okay. So now we relate all the things together, what we are getting. Come on, observe what I said. First, we observed that successive, right? Successive. Okay. Successive terms, right? So succession. Can I take this as a succession of terms according to the succession of terms formed by means of one single rule, right? Succession of terms formed by a single rule that can be called as our sequence. Understood? What is the sequence? Here, succession of terms formed by a rule. One rule. You observe. Suppose I ask you what will be the next number. What do you say? Yeah, definitely you are saying that it is 5, right? Yeah. Why? Because the next number goes on incremented by 1, right? So the successive number will be the successive number for 4 is 5. Yes. So what will be the successive number for 20? It is 25, right? Now what is the successive number for this in this pattern? Say it will be -12, right? It goes something like this. Say I am taking one more thing. The successive terms. The successive terms followed by a single rule can be called as a sequence. Okay. Each term can be represented as T1, okay, T1, T2, T3, T4. That means first term, second term, third term. Those are represented by generally algebraic letters, right? Now, if you go for a function, we know function, mainly if you talk about function, there are two things, right? Function is a kind of process, right? Okay, if it is a kind of process, and then definitely if it is a process, if you take a computer, so we are giving input to the computer and CPU does some process, right? And we are getting the output. Okay. In the similar way, now we are giving something to the function. So what kind of things we are going to give to the function? That can be called as domain. Yes. So whatever the input we are giving to the our function is nothing but in terms of x, right? So indirectly we are giving some values to x. That is nothing but domain, right? And now when you give some value to x, definitely we have the function does some process, okay, and gives output, right? So that is a range. Can I call that as range? We know about already functions, right? So when we talk about function, definitely domain and range, these two are the main keywords in the functions, right? So here, a sequence of a function whose domain is natural number set, whose domain is natural number set. If the domain is natural number set means what is the meaning? So we are giving any kind of function you take. Okay. Say I am taking y is equal to 2x plus 3. This is one function. Okay. Here y is a function of x, right? So y is equal to, can I call this as y is equal to f of x? Okay. Now here I am giving some values to x. Let us give one value. X is equal to 1. So 1 is a domain, right? What will be the range? So the range will be 5, right? So here the range is 5. So 1 corresponds to 5, right? In that way we can write. Now here if the sequence whose domain is n, that is domain belongs to the natural number set, okay, and the range which is subset of r, then that can be called as a real sequence. What is a real sequence? What is a real sequence? A real sequence is a sequence whose domain is a natural number set and the range is subset of R. Why here? The subset of R means under R comes under N, W, Z, Q, right? All the things come. So a range may be either a rational number. So rational number means it can be integer, whole number or natural, right? Yeah. Very good. Now, let us move to something new thing. What is our new thing? Let us look at this. Okay. Say, I am taking now, if before case we took 1, 2, 3, 4, right? So on like this I took. Now, what I am doing is just I am keeping plus sign between them. You observe now. Okay. You observe. Now, the terms are going to be added. Yes, the terms are going to be added here. Or the terms may be subtracted. Say, let us take 3 minus 4 minus 5 minus 6 minus 7. Okay, like this. So, can we call this as algebraic sum, right? Algebraic sum, that is either positive or negative, right? Algebraic sum, okay? If the terms of a sequence, so these are terms, we know, T1, T2, T3, T4, right? So if the terms of a sequence are connected by either positive or negative sign, okay, then we are getting some expression, right? Algebraic sum, then the algebraic sum, whatever we are going to get, that can be called as series. So what is series? If the terms of a sequence are connected by either plus or minus, the algebraic sum, we are getting the result, no? The algebraic sum we are getting, that can be called as series. Okay, generally the series can be represented as, say, let us take the terms here, a1 plus a2 plus a3 plus so on, okay, an. If it is a sequence, then If A1, A2, A3, suppose if I put like this, let me tell you one thing. A1, A2, A3, A4, okay, so on. This is the sequence, right? So when the sequence becomes series, so when it is connected with either plus or minus, okay, then it becomes a series, right? So do you got the difference between series, sequence and series? So A1, A2, A3, A4, simple terms is a sequence, whereas the terms which are followed by either positive or negative sign, those are connected by either plus or sign, and the algebraic sum we are getting, that can be called as series. Yes. So let us look at some examples. Say 1, 2, 3, 4. This is one series sequence, right? 1 plus 2 plus 3 plus 4 plus so on. This is series. Okay, understood? Yeah. Now we can observe that different types. Like, say I am taking. Let me take 1, 2, 3, 4. I had given. Okay, and here 1 plus 2 plus 3 plus 4. Okay. Next 5, 10, 15, 20, 25. Okay. This is one pattern, right? 5 plus 10 plus 15 plus 20 plus 25 plus so on. What is the difference? You observe. What is the difference between the top one and first one and the second one? If you observe, here there are finite terms, right? And in this also, there are finite terms. Okay. So this can be called as, we can call this as finite sequence. Okay, finite sequence. And this is finite series because the numbers are stopped, that is limited. Okay, we can count, that can be called as finite, we know that. Okay, and here if you observe in the second case, the numbers going on like that, right? If you put three dots, what is the meaning? They are going on like that. That means infinitely they are going. Okay, so there is no limitation here. So this can be called as infinite sequence and this can be called as infinite series. So finite series, finite series, and infinite sequence and infinite series. Okay, infinite series. Now, a series is finite or infinite. It mainly depends upon the number of terms, right? Number of terms. Okay. The sequences, if you follow suppose I can write like this also, no? Let me take 1, 3, 8, okay, 11, and then 20, and 56, 98. Yeah, I can write like this also. Okay. Here, is there any rule following here? Okay. There is no rule at all, right? So if you follow particularly a certain pattern or a rule, it can be definitely called as progression. What is it called? Progression. So we can define now easily progression. The sequence whose terms. So sequence maybe that means sequence it may follow it may have some kind of rule, right? And if you observe the sequence whose terms, the terms follow a certain rule or a pattern, it can be called as a progression. Okay. Now you observe what are the different types of progression. If you observe, there are mainly three kinds of progressions. First one is arithmetic progression. arithmetic progression. Next, geometric progression. Next, harmonic progression. Mainly these three. In addition to that, there are some mixed progressions. Okay, those are AGP. We will study these later. First, let us observe arithmetic progression. Okay, what is arithmetic progression? Now, you observe, I am giving one example. Let me take one example like this. One simple example I am taking 1, 2, 3, 4. Okay, 1, 2, 3, 4. Now, in this you observe here, this is first term already, we know, a second term, third term, fourth term. Yeah, it goes like this. I am asking you to find the 15th term. If I ask you what might be the 15th term in this progression, then how do you find? So if I ask you what will be the 6th term, 7th term, you can easily say. If I ask you 100th term, then it is very difficult to write up to 100 terms. Okay, it is time taking factor, right? So how do you find now the particular term? In that, we know in algebra generally what do we do? Generally we are writing, suppose I gave you any kind of thing like how come on, calculate the value of 23 square. So what you do generally? 20 plus 3 or something you are writing and you are applying the standard form like that. No? In the same way, now we are writing the standard form of this. How to find the any kind of term in the arithmetic progression. In the arithmetic progression, AP means arithmetic progression. What will be the general form? What will be the general form of arithmetic progression? And how do you find the any kind of term? Okay. What are the main things which are in AP? We will study one by one clearly. So after completing this, you will be crystal clear about AP. Let us look at this first one. Now, what will be the general form of AP? I told. So how do we write this first? Let us look at this. So 1. This 1 can be written as, how you are getting this 2? 2 we are getting just by adding the previous number to 1, right? And how you are getting 3? How you are getting 3? 3 also you are getting just by adding 2 plus 1, right? Next, this is 1, 2, 3 and 3 plus 1. Yes, 4 plus 1. Like this you are getting. Okay. So this can be called as A. First term is A. Now if you observe the difference between the first and second, how much? It is 1. Now you observe the difference between first and second. Again 1. Third and second. Sorry. And this is fourth and third. Again 1. If you see the difference between the successive terms, it is always same, right? The difference is same. That difference can be called as common difference. This is the key word for AP. Okay, this is the key word for AP. What is that? Common difference. CD. What is it called? CD. Common difference. The common difference is same. Then you just blindly you can say that will be the definitely AP. Okay, like that you can easily identify the given progression is either AP or GP or HP or any kind. Okay, yeah. Now, so this is A I said. What is the common difference here? We got, so common difference generally denoted by CD or D simply. Okay, D. So here, what is D? D is 1, right? D is 1. Okay. So A is 1. So you are adding now, you observe. A here is A plus D, right? Now, in this case, you observe with respect to A, I am writing. So it can be written as 1 plus 1 plus 1, right? Or otherwise, I can write, how do you write? A plus B. So this is again A plus 2D. Can I write A plus 3 into 1, right? 1 plus 3 into 1. Here, 1 plus, can I write 2 into 1? 1 plus 4 into 1. Yeah, that is A plus 4D, A plus 3D. First one is A, second one is A plus D, that is 2. Sorry. Next, A plus 2D is 3, A plus 3D is 4, A plus 4D is fifth term. Okay, like this. It goes on like this, right? So, what is our general arithmetic progression? General form of arithmetic progression is A plus D, A plus 2D, right? A plus 3D, okay? And A plus 4D. If I go on writing like this, generally up to how much means generally we will, if the number of terms, no? So number of terms, right? That's why we are taking it as n, right? So I want to, if I go on writing like this, I want to write nth term. How do I write? Say, how you are writing? So first term is just A. That means A plus 0D. Can I write this? A plus 0D. First term means A plus 0. 1 is less, right? Next, second term is A plus 1D, right? Third term is A plus 2D. That is 1 less, right? The the coefficient of D is 1 less than the given term, right? So in this way, if I go on writing, I am writing nth term, I am saying. You see, nth term. So what I do? Generally, I have to less this n 1, right? That means n minus 1. Can I write? So A plus n minus 1 into D. This is our general term. This is our general term to find any term for the given AP. Okay. So what is that? Tn is equal to, so this is nth term, right? Tn. Can I write this as nth term, which is equal to A plus, how do you write? N minus 1 into D. Okay. A plus n minus 1 into D. This is our nth term. Understood? So here, first term is A and common difference is, you know how to find the difference. We already calculated for this example, right? So what is that? 2 minus 1 is 1, right? Okay. So 2 minus 1 is 1. So common difference is 1. In the same way, and Tn is equal to, because n is here, what n represents? Here, this Tn. This is very important point. Don't confuse here. The Tn means nth term. Okay, nth term. Here, n means this is what is nth term. Nth term is Tn. Number of terms. That means, say, I am giving for which term, or you can say nth term. This is nth term, direct nth term. What kind of term? That is n. Okay. Let me take one example so that you will get a clear idea on this AP. So what is our Tn is equal to A plus n minus 1 into D. Okay. What is A? A is first term. These are very important. First term. And D is common difference. Tn is nth term. Okay. N is what kind of term? Okay. Let us take one example. Let us take, say, I am taking an example 1. Say, let me take 21, 25, and 29, so on. I want to calculate T70. T70. So, according to this general form or standard form of an AP, to find the nth term, so here we are finding 17th term. Okay, 17th term is equal to question mark. So first write given. What is given here? Given is A is equal to, A is first term, no doubt, right? A, what is our general arithmetic progression? A plus D, A plus 2D, so on. A plus n minus 1 into D. Okay. Now, here T17 we are calculating. So, A is equal to 21. What about D? D is equal to what? T2 minus T1, or this is T3 minus T. Anyway, you can take, because what is the thing in order to recognize whether the given progression is AP or not? What is the thing you have to do is, first let us check the common difference. Come on, check it. So T2 minus T1 is equal to T3 minus T2. Yeah, T2 minus T1. This is second term minus first term is 4. And third term minus second term is also 4, right? So we are getting the same. Common difference is same. We can decide that progression as AP, right? Yeah. So common difference here 4. Okay. Now can we calculate T17? Yeah. Come on. Let us do fast. T17 is equal to A plus, first let me write that Tn is equal to A plus n minus 1 into D. Okay. If you write under it, then it will be good. T17 is equal to A is how much? 21 plus, what is n here? 17, right? 17. N is 17 minus 1 times D. Okay. So 21. D is how much here? D is 4, right? Okay. Now 21 plus 16 into 4. How much you will get? 21 plus 16 4s are 64. Okay. 4 plus 1 is 5. 6 plus 2 is 8. Okay. You do like this. Horizontal division is easy when compared to the vertical division. Normally, the students, what they do? They are going to do like this 21 and 64. And again, they are going to add like this. Don't go for this. Why? If you want, again, you are copying the same numbers here. Okay. Sometimes while copying, if you do any mistake in any kind of numbers, then there will be an issue, right? So for that, if you try to add here units, you may not you may not do any mistake, right? By practice, then it will be very easy. At the beginning, yeah, it will be difficult. Not only for you, for me also it is very difficult at the beginning. If you practice it, then it becomes easy. You can do calculations perfect. Why? Mathematics is, if you are a mathematics student, then you should have two things. First one is speed, and the second one is accuracy. These two are very important for any mathematics student. Okay. So here speed. So you're doing very fast, right? Without copying these numbers, right? And accuracy, because accurately you are calculating, you are doing addition. Okay. So being a mathematics student, try to follow these kind of things or techniques or tricks, whatever maybe you can take. Okay. Try to follow like this. So you got how much? How much we got? We got this as T17 as 85. Okay, understood. In this way, we can calculate any kind of thing. Here, how many variables? Okay, you know, any equation or anything, any expression or any kind of equation, you know the variables, right? So here Tn is a one variable and A is and four variables. So out of these four variables, any three are given, you can calculate the other thing, right? So let me do one kind of thing in the same way for AP only. Let me take if the otherwise I'm taking if A is equal to -2, okay, and D is equal to -3, then find Tn. In this way also they can ask. So the same thing, okay, right? Tn is equal to A plus n minus 1 into D. Okay. How do you calculate? A is -2 plus n minus 1 into D is -3. Okay. How do we calculate Tn? How much you will get? -2 minus 3n plus 3. Okay. -3n plus 1. This is our Tn. Okay. Next, I'll give one more question to you. Let us do one more question, that is, which term of AP which term of AP 5, 2, -1, so on is -22. Here, this is the indirect question. Yeah, which term of AP? So what we have to find for which term? The term will be -22, right? So here Tn is given. Yes, Tn is equal to -22 and A is equal to 5. And what about D? D is equal to, you see, 2 minus 5. 2 T2 minus T1, right? So 2 minus 5 is D is -3. Now we got the three things, so we can easily calculate the value of n. Yes? Come on. Let us calculate first. Tn is equal to A plus n minus 1 into D. Okay. What is Tn? Tn already given, right? -22 is equal to A is 5 plus n minus 1 times D is -3. Okay. Yes. Come on. Calculate. So -22 is equal to 5 plus. So with -3 I am multiplying. So I am writing directly -3 and minus into minus plus 3. Okay. What do we get now? So here I am doing. So from right to left I am moving. So in Vedic mathematics also, generally what do we do in addition? In addition, what do we do? Addition of subtraction. Let us take 50 54 minus 39. How do we do generally? We are moving from right to left, right? In Vedic mathematics, we are doing from left to right. Okay, left to right. Then it becomes easy. So if you want these kind of Vedic mathematics things, you can watch my videos. Okay, I am starting in coming videos. I am doing Vedic mathematics videos. Okay, Come on, let us look at this. So that I am going now. Minus 22 is equal to 5 plus 3 is 8. 8 minus 3n is equal to minus 22. Okay. Now, what do we get? So, minus 22 minus 8 is equal to minus 3n. Minus 30 is equal to minus 3n. So, both sides cancel. N is equal to 30 upon 3. So, n is equal to 10. So, which is our term? Our 10th term is minus 22, right? So, 10th term T10 is equal to minus 22. Yeah, so they gave already here. So, because this is not indirectly, I can't say that it is indirect. It is almost direct. Why? Because that term is given here. Three things are given. They are asking us to find only the variable that is n. Understood? Let me move to the next part of the AP. Let us move. Yeah. Now we are using the terms 5. I am taking the series 5 plus 2 minus 1. Here I am using this series like this. You observe now. This is series, no? Yeah. Or you can say this is arithmetic progression also. Okay. This is series. You take this as a series. Now, what I am doing, just I want to add all the things of arithmetic progression. Different terms I want to add. Terms adding. Okay, how to add the term? Let me take one example. Say, first term, we already know the terms. So, I am taking directly, I am going to the terms. A, first term is A, second term is A plus D, right? And the third term is A plus 2D, okay? So on, A plus n, A plus n minus 1 into D, okay? This is our, wait, I will write again from the beginning, okay? So that it will be fit here. A, okay, plus A plus D plus so on, right? So before, what will be the term before A plus n minus 1 into D? Can you guess? Yeah, right. A plus n minus 2 into D. Very good. Plus A plus n minus 1 into D. Correct? Now, what I am doing is what I am doing is I am deriving or I am getting the standard form of adding the terms in the arithmetic progression. Okay? That can be called as, that is what I am doing. I am finding the sum of n terms. No doubt we have n terms in the arithmetic progression, right? So what we are doing? We are adding. That means we are finding the sum. So that can be called as Sn. What is that called? Sn. So Sn is equal to, can I write this as Sn? Because I am adding all the terms of up to n terms. Okay. This is the thing we got. Now, how to get the standard form in order to calculate the sum to n terms? Now we are doing, right? So for that, simple derivation we are doing. Okay. So the mathematicians followed, we are following. Okay. Let me do that. Yeah, what we do now, Sn is equal to, just what I am doing, I am writing, can I write, because A plus B is also, can I change the order? Yeah, I can change. So simply I am changing the order of these terms. I am changing the order of these terms. So first term I am making it as the last term. So from last term I am writing simple in reverse way. Okay. A plus n minus 1 into D plus, this is second term, right? A plus n minus 2 into D. Okay. plus so on, right? So what will be our loss before term? That is a plus d, okay? And the last term is a, correct? Yes. Just what I did, just I flipped it, okay? Just I flipped it. That means the first and last terms, I reversed it, okay? Now, what I am doing is just I am adding all the things, okay? Come on, add. Let me add the things left side and a right side. So what do we get? So Sn and Sn becomes 2Sn, okay? 2Sn is equal to, you observe now. So if you observe the similar terms, so this is same terms, no? So x and x, you take this total thing as x, this total thing as x, this total thing as s. So this is 2a plus n minus 1 into d, right? 2a, or you can add from the top and bottom also, okay? So this is 2a plus n minus 1 into d, we can write, okay? Then at that time you have to take common and all those things you will get. So easy way I am doing. So the similar terms, because we are writing the same expression, same RHS down. So we have all, each and every term is 2. That's why I am adding 2 to before. Then it becomes easy to derive. Okay. Okay. 2 times 2a plus n minus 1 into d. Okay. And plus, again you observe a plus d and a plus d, right? A plus d and a plus d, and also 2a 2a plus 2d, okay? Plus, next a plus n minus 2 into d. Okay, let me do otherwise just by adding. Why we go like this? Okay, let me do like that only. Why to confuse you? Yeah, let me add this a plus n minus 1 into d, that is 2a plus n minus 1 into d. Okay, plus, and here you see 2a plus d plus a plus n minus 2 into d, right? Plus so on a plus n minus 2 into d plus a plus d plus last term I am writing here plus this is 2a plus n minus 1 into d. Let me write one more step so that it becomes, okay. Now what do we get? So this is 2a plus n minus 1 into d, okay, and plus. So here, if you go on adding like this, no? If you go on adding like this 2a plus n minus 1 into d, so on like this, you are getting how many times? N times, that I forgot. Okay. N times you are adding. Okay. That means a plus a, 2a, 2a plus n minus 1 into d. Okay. Plus so on 2a plus n minus 1 into d plus so on n times. Okay, n times. Then you observe, so this can be n times means each and every 2a plus n minus 1 into d, 2a plus n minus 1 into d, 2a plus n minus 1 into d, 2a plus n, like this. So n times means, can I say n times 2a plus n minus 1 into d? 2a plus n minus 1 into d. Yeah, here you are adding many times. So repeated addition is multiplication. So in this way I did it. Okay. Now Sn is equal to now n by 2 into 2a plus n minus 1 into d. 2a plus n minus 1 into d. So this is our sum to n terms in the arithmetic progression. Okay, sum to n terms. So you observe this can also be written as Sn is equal to n by 2 into, so 2a can be written as a plus n minus, so 2a is a plus a plus n minus 1 into d. You know what is a plus n minus 1 into d? A plus n minus 1 into d is our last term, right? So the last term can be represented as L. Okay, last term Sn is equal to n by 2 into a plus L. Okay, or Sn is equal to n by 2 into 2a plus n minus 1 into d. So this is our sum to n terms of a arithmetic progression. Got it? Let us do one example related to this question. Come on, let us complete fast. Let me take one series, one progression, 0.5 minus 0.5 minus 1 minus 1.5, so on. Okay, I want to calculate S10, sum to 10 terms, S10. So here S10 means here n is equal to how much? First let us write, because what are the variables we have? Sn is equal to n by 2 into 2a plus n minus 1 into d. Okay, so for this you observe here a is equal to, what are the variables we are going to write? A is equal to minus 0.5 and d is equal to t2 minus t1, right? So what is t2? Minus 1. This is t2. This is t1, right? So minus 1 minus of minus 0.5. So it becomes minus 1 plus 0.5. So this is minus 0.5. So this is our d. So this can be written as, so minus 1 by 2. Can I write 0.5 as 1 by 2? Okay. Now S10 is equal to, you got n by 2. So how many terms here? N also we have to write now. N is equal to 10. So I'm writing S10 is equal to question mark. Okay. Now S10 is equal to n by 2. First let me write the formula and then I'll go with the substitution. N by 2 into 2a plus n minus 1 times d. Okay. You keep this in bracket and then whole d. Okay. That is very important. S10 is equal to 10 by 2 into 2 into a. A is, what is our a? Minus 0.5 or 1.5. Can we take it as 1.5? Then calculation becomes easy. Yeah. Sorry, 1 by half minus half. Okay. 0.5 is 1 by 2, no? Plus 10 minus 1 into d. What is d? D is a 2a. A is, so a is also 0.5, no? Yeah. A is 0.5 and d is also 0.5. Both are negative and 0.5. Yeah. 10 minus n minus 1 into d. What is d? D is again minus half. Okay. So what do we get? 5 into, this becomes minus 1 plus 10 minus 1 is 9 minus 9 by 2. Okay. So what do we get? 5 times minus, so I'm taking LCM, minus 2 minus 9. Okay. 5 times minus 11 by 2. So how much you'll get? Minus 55 by 2. That is equal to minus, so 2 times, 2 7 times and 0.5. So minus 27.5. Okay. Like this, we can easily calculate sum to n terms of an age. So what we did in this video, like finding what is a sequence, what is series, what is the difference, and how to find what is a progression, okay, and what are the different types of progressions, and after that, what is an AP? In AP, what is the standard form of AP? Okay, and in that, how do you find the any kind of nth term of an AP, and how to find the sum to n terms of an AP. Okay, so these are covered in this AP. So in next video, we are going to observe what is GP and how do we derive the nth term, and how do we find the sum to n terms of a GP, and also we cover, because in this session we are not covering the arithmetic mean. Okay, that also will cover in the next video. Okay, uh, thank you.